Good afternoon, and congratulations on having the International Symposium on Weather Controllability. And I hope this research community will expand more and more through this symposium. This is the motivation of our research. This panel shows three-dimensional vortex index just before the cumulonimbus cloud generation, simulated by large eddy simulation with 60-meter resolution. This is simulation result, but in our weather radar analysis, this vortex tube can support the initiation and development of cumulonimbus cloud. And it can be seen that some vortex tubes originate from the ground surface. This means changing these vortex tubes could help control heavy rainfall. This is aims of our project, and there is two big problems. The first one is to develop the control technology, and our group is focusing on this part, operation to weaken the trigger of heavy rainfall. And the second problem is how to create a philosophy of weather control. So in my feeling, the relationship between a human and nature is something conflict. So we have to change the mind like this. So we have to understand human is living in bottom pocket of nature toward 2050. So based on this mind or philosophy, we have to develop the control technology. This is a key concept of our project. This is R&D teams. We have three teams. The first one is development of control devices based on numerical simulations. And team 2 is developing a real-time control system. And team 1 and team 2 is the technology group. And team 3 is related with LC and RRI research. And they evaluate the impact of weather control, and also they will develop or create a philosophy of weather control. And the important thing is we established the feedback structure like this. So question is, what is the impact on nature and society? And the team 3 will answer. In my talk today, I will introduce the weather control simulations, and I will introduce three types of control devices. The first one is wind turbines, and the second one is offshore curtain, and the last one is cloud seeding. Okay, today I will these simulations respectively, but in the future we have to consider the combination of these multiple devices. Okay, let's move on the wind turbines. So this is a result of weather control by wind speed operation assuming wind turbines. And we, under the target of this event is one single cumulonimbus cloud like supercell. And this event is named the Toga River event, occurred in 2008 in Kobe City. And in the operation simulations, we set wind resistance here, just near the upstream area of convection. And as a result, the rainfall intensity was suppressed by 27% at peak time. This is rainfall suppression mechanism. And we focus on the suppress the vertical vorticity here. In control simulation, by the wind resistance, the vertical wind shear becomes weak like this, so that vertical vorticity becomes also weak, and then updraft becomes weak. This is the first mechanism. And second suppression mechanism is the balance between dynamical and thermodynamic fields is mismatched by the wind speed of variation. So in the case of no control, the buoyancy and the convergence makes the updraft at the same location. But in the control simulations, updraft by convergence and updraft by buoyancy was separated like this. So this is the second mechanism. Next, we conducted the sensitivity experiments. For example, we changed the duration, timing, size, location, and quantity. And this is a result. And this is a time series of rainfall intensity. And black solid line shows the non-operation case. And as you can see, high sensitivity when the position and size are varied along the wind direction. In particular, location in the east-west direction. This is corresponding to the main wind direction. In the previous simulations that I have talked about so far, we don't care so much about the size of wind turbines. So from here, we have to care the realistic size of wind turbines. And we checked the sensitivity with respect to the installation position on one grid. And this one grid is corresponding to two giant wind turbines. And this is a result. And this is a ratio of peak rainfall intensity to the non-operation case. So less than 100% is indicated the suppression. And this circle indicates the location of convection core. And as you can see, basically the suppression effect is greater when installed on the upstream side near the convection core, here and here. And the best performance shows here. This is a 17% suppression when we use the two giant wind turbines. However, the opposite effect was simulated when installed in the center of the convection core, here light blue colored area. The reason for this is that the wind resistance weakened the wind, while the water vapor in the lower area was lifted a little higher up. And so wind suppression and water vapor lifting is a relationship of trade-off. And we checked the multiple regulation analysis, and the result is the weights of the wind suppression and water vapor lifting is the ratio of 1 to 2. So it's important to look at how to suppress the wind on top of the water vapor without lifting it. Next, we conducted the coupling simulation between heavy rainfall control simulation and flood simulations. And it showed the potential to reduce peak river discharge by 26% by operating wind speeds with wind turbines. And this is one big result, I think. And also, in the case of this Toga River torrential rainfall case, the overflow did not happen. So important thing is evacuation of people inside the river. So in this sense, it's important to control not only the peak discharge, but also the gradual rise of rainfall. And we also conducted the ensemble simulations by changing the location. And it's effective when it rains in mountainous areas due to time delay caused by soil layer thickness. In this case, we could save 3 minutes for evacuation. So someone feels 3 minutes is not so big time, but 3 minutes is enough to evacuate from the river. Anyway, gradual rise of rainfall is one of important viewpoint. So we checked the time delay in the previous simulation. So please look at the color. The color shows the delay time to peak. So blue shows no delay compared with no operation case, and orange color shows the 2 minutes delay compared with the no operation case. So if the purpose is set to evacuation time, there is no need to worry about a slight increase in rainfall. A time delay is possible by simply aiming upstream of convection core. And so now we are examining whether this tendency is true or not for other heavy rainfall events. This is also interesting result. And first, we reduce the height of wind turbines from 300 meter to 200 meter in order to consider realistic size. And so the best performance of this wind turbine's height was 7% peak rainfall intensity suppression. And here we focus on another mechanism of initiation of heavy rainfall. In this event, north wind is one of trigger because this is cold gust from the other cloud system. And we set the wind turbines to suppress this north wind, and the result shows 5% peak rainfall intensity suppression. And so we also check the effects of installation in 2 locations. So we combine this main wind directions suppression position and also suppress the north wind position here and here. And the result was 16% suppression. But interesting point is this 16% is greater than the 7% plus 5%. So there is a possibility to make the big effect using the combination. In order to express the effects of wind turbines precisely, we conducted a large eddy simulation at the surrounding area of wind turbines like this. And the green color shows the suppression area of wind speed. And you can see the wind reduction area is very complicated, especially at the bottom, downstream of here, called cluster wakes. And this is a vertical cross-section of wind turbines. And this is a sensitivity experiment of the atmospheric stability. The top panel shows the neutral and middle panel shows the unstable condition, and the bottom panel shows stable conditions. So the turbulence created by the incoming airflow and the turbulence created by the wind turbines wake interfere strongly with each other. So these findings will be generalized and feedback into the heavy rainfall control simulations in the future. From a viewpoint of manufacturing, now we are considering not only a wind farm like this, but also a floating cluster wind lens turbine like this. And this is developing by Kyushu University. And characteristics of this type is high wind resistance. This is good for weather control. And also high power generation efficiency, but high cost. But anyway, we have to collaborate with power generation company for multi-purpose use. So not only power generation, but also weather control. So this was the end of the explanation of wind turbines. And the next control device is offshore curtain. This aims is controlling water vapor inflow from the ocean and then suppress heavy rainfall. So this offshore curtain is suspended by kites, and currently we consider a size of 1 kilometer square. And characteristics of this offshore curtain is that this can be moved on the sea. And we found that the position is important. So we conducted backward trajectory tracking analysis, and we conducted the sensitivity analysis regarding the location of the offshore curtain. Totally, we conducted 48 cases simulations. This consists of 3 patterns in height multiplied 6 patterns in east-west direction. And this is the result of control simulation. Left panel shows no operation case, and middle panel shows operation case, and the red color shows the difference between two, and blue color shows suppression. And so, and this is a result of the most rainfall suppression case of 48 cases. And the suppression value was 34% suppression. And this target is the linear convective system occurred at the northern Kyushu area in 2017. And so because this is a linear convective system, so this rain band consists of 5 to 10 cumulonimbus clouds. But it's interesting that the shape of the rainfall amount is not so different. And this is the result of 48 cases. So 3 patterns in vertical layer multiply 6 patterns in west and east directions. And the blue color shows the suppression, and the red color shows the increase. And this is a change in area maximum of 3-hour accumulated rain. And so range of change was from minus 34% to plus 16%. And the lower layer shows the suppression. And I thought that the impact would be greater closer to the location of the heavy rainfall, but this is not the case. So I think it's kind of interesting. Here and here shows the greater suppression result. Okay, last control device is cloud seeding technique. In order to express the cloud seeding, so we operate the number concentration of ice crystal nuclei in the MEXT scale model. And seeding area is set to upstream area of heavy rain. And seeding height is also set to this height. And seeding timing is set to 3 hours before the increased precipitation. And target event is also linear convective system occurred at Kyushu area, but different event. And this is the result of cloud seeding simulation. Left panel shows no operation case, and right 4 panels shows operation cases. And it can be seen that the strong heavy rainfall area are reduced compared with no operation case, but weak rainfall area are increased. So totally, the cloud seeding has a smoothing effect. And next we conducted the 2-step cloud seedings. And the last simulation we conducted cloud seeding on area A. And in addition to that, we set the not only A but also B area. And this shows the better result compared with 1-step cloud seeding simulation. So maximum accumulated rainfall shows the double effects compared with 1-step case. However, the area average of accumulated rainfall is very similar to non-operation case. So finally, cloud seeding has the effect of smoothing. But I think reducing the maximum accumulated rainfall by roughly 20% has a very big effect for water management. And this is the suppression mechanisms. So by first step cloud seeding, suppression of updraft due to falling precipitation particles. And the effect of second step seeding is the cooling effect by evaporation and competitive growth due to overseeding. And the last technique of cloud seeding is pinpoint seeding. The aims of this pinpoint seeding is reduce the area size of cloud seeding. And so seeding area is set to several grids with strong updraft area in the early stage of cumulus development. So in this case, we set the top 3 grids with strong updraft in calculation domain 2 that has a 0.3 kilometer resolution. And the timing of cloud seeding is set to 2 patterns, 6 hours before the peak time and 3 hours before the peak time. This is the result of pinpoint seeding. And this 3D view shows the cloud microphysics. And orange color shows the gravel. And it can be seen that the gravel at the leading edge of linear rainbands are disappeared by the operation of cloud seeding. And this is a score, rate of change of rainfall from no operation case. And we carried out the sensitivity simulations, timing and height and duration. And generally speaking, the longer duration has a good score, and there's no tendency in the height, but the timing, earlier timing has better performance compared with later timing, and the best performance shows in the case of both 6 hours before seeding and 3 hours before seeding. So 2 steps pinpoint seeding has best performance. However, area average rainfall shows no big difference compared with no operation case. So finally, the cloud seeding has the effect of smoothing. And this is the estimation of the amount of cloud seeding. So in this case, we assume dry ice seeding, and there is some assumptions, but roughly estimation, we need the 1,000 kilogram dry ice is needed for pinpoint seeding. But I think this value is realistic. Summary. So I introduced 3 types of operation devices: the wind turbines, offshore curtain, and cloud seeding. And so common things among these 3 devices was the suppression amount in a good case is about 20%. And also, the shape of rainfall is similar to non-operation case. And this result was very important because if the location changes, so students cannot accept it. And the most interesting things for me was that the multi-operations, for example, multi-times operation or multi-locations operations, shows a potential on better performance compared with the single operations. Okay, that's all my presentation. Thank you for your kind attention.